Hey everyone, once again. This is our last talk for the day. Let's give a big round of applause for Burkay Gur from Coinbase.
Hello everyone, welcome to my talk. And thank you very much for the organizers. It was a great experience, coming down from San Francisco to Lisbon and like seeing all the beautiful city, and yeah, thank you for your hospitality. So yeah, today I'm gonna talk to you about a bunch of things, about Coinbase and mainly about preventing fraud at Coinbase and how we do that and like what it looks like, and also gonna talk a little about account security. So yeah, just to introduce myself, I'm a data and machine learning engineer, and I am in my 6th year right now in the Silicon Valley, and I'm actually originally not from there. I'm from Turkey, which is not too far from here, but I did my college degree in the United States, and I decided to stay there to work, and I've been an immigrant in the US for 11 years now. So if you guys are, having similar experiences or like interested in talking about what it's like to live in the US or work in the Silicon Valley as a foreign person, come find me afterwards. I have quite a bit of experience doing that. But today we're gonna talk about what I do and what we do at Coinbase. So who knows about Coinbase here? Okay, so I'm just trying to gauge like the level of sort of where you guys are at with digital currencies. Who knows about like cryptocurrencies? Okay, all right, cool. So at Coinbase, what we're trying to do is we're trying to build an open financial system. And what does that mean? It's kind of like a sort of a interesting term, right? So what we mean by that is we're trying to provide people what like the internet provided in like the early 90s and like how it transformed like the way that people access information. We want to do the same thing with currency, with the financial system. So like in a lot of parts of the world, it's very difficult to like have a bank and like have access to financial systems. So what we're trying to do is we're trying to bring the digital currency technology to the whole world and make it really easy to use so that we can later on build these financial instruments on top of the digital currencies and make sure that it is as accessible as the internet. So just by having an internet connection, you should have access to financial instruments. So that's our mission. So just a little more about Coinbase. The slide kind of explains a lot of the things, but what I want to mainly talk about is the amount of sort of value we're holding within Coinbase. It's around $20 billion. So that's like, a very big portion of actual, like the whole cryptocurrency market cap. That's like an interesting number. It's grown a lot over the past, you might notice too, like especially end of last year. And the other interesting fact is we are 250 people working on this product, and we're in 3 offices. So we're in San Francisco, that's sort of the headquarters. We're in London, and we're also in New York. So, and we're heavily recruiting in all of those places. I'm gonna do the selling up front. We're heavily recruiting in all of those places and like trying to expand in Europe as well. So just to cover like the sort of list of currencies we have on our platform, for a long time we actually had 3 currencies. And we just recently added one more, which is Bitcoin Cash. And I won't go into too much detail on that, but if you want to learn about it, you can find me afterwards again. What it is basically a Bitcoin fork. And won't go into detail what a fork is. That would take, longer time. So we have Bitcoin, Ethereum, and Litecoin. And the way we choose these currencies is mostly like the demand and like the usage patterns on these currencies. And I want to talk about like the analogies here a little bit. And this is sort of like the current state of the world, where like these can actually change because there's current developments like happening on all cryptocurrencies at all times. So, but Bitcoin currently, you can sort of think of it as digital gold. So it's people, like the main use case of it is like storing value and investment. And it is unfortunately harder to move around because the fees for it has been really high recently. But we have some alternatives, which we call like the digital silver sort of, which is Litecoin, which is like sort of lower fees and it's like higher throughput. So for like daily transactions. So that sort of satisfies more of the payment use case. And we have Ethereum, which is digital gold, which means that it can fuel a lot of the sort of other applications in the whole like, financial application stack. What Ethereum does differently from Bitcoin is that you can enable these things called smart contracts, which allows you to write like functional applications. So just to give an example, you can sort of have whereas like it's really difficult to have something functional in Bitcoin, you're still able to do it, but Ethereum makes it a lot easier to actually make some computations on the network. So there's like an interesting thing happening recently, and this graph reflects that. So what's happening is, until like 2017, the Bitcoin percentage of the market cap was like sort of constant, around 80%. And around 2017, we've seen something like the sort of emergence of altcoins, like alternative coins, and they sort of started sharing like the Bitcoin's share in the whole market. And there's a very good reason for that. And Ethereum and Litecoin are one of these. And those coins are sort of trying to really push the boundaries like for different technological developments that Bitcoin does not have yet. So we think it's like a very good thing to have a lot of different approaches in the whole community and have different applications and different technologies emerging. So we see this as a very healthy change. So most of you know as like Coinbase as like sort of a one-stop shop. Like you can sort of put some fiat in, like your dollars or euros, and get out some cryptocurrencies. But there's actually a lot more going on underneath. So like what Coinbase is actually, we're trying to build a whole financial infrastructure along with some applications on top. So the way we look at it is, we sort of look at it in two parts, where we have the sort of more infrastructural components like Coinbase.com, GDAX, which is our exchange for more like retail, not for retail, but like institutional investors. And we have Coinbase Custody, where like these institutions can hold bulk of their holdings. And then we have applications like Coinbase Commerce, where you can, if you're a merchant, where you can enable your platform to accept cryptocurrency payments. And Toshi is another one of our apps that allow you to browse the Ethereum network and interact with these applications on the Ethereum network. So this is just going into more detail. And so what are we going to talk about today? So I'm going to make a little bit of a diversion here. And since today's topic is security, and I'm here to talk about, fraud and account security in a digital currency exchange, right? Because like it's a very new concept, and a lot of the things that apply to more traditional banks doesn't apply, and there's like more requirements and like new things we come across. So I'm going to share some of our findings and talk to you about how we prevent it. So to start with, just to like give you an idea of like what I mean by payment fraud, we classify payment fraud as like when you don't have your account with Coinbase. So payment fraud comes from like an outside, some kind of like your stolen credit cards or like something that without your authorization, and you find this charge like from Coinbase and then reverse that charge. So that's what we classify as payment fraud. And an account takeover is where you have an actual Coinbase account and that gets, you know, some bad malicious actor takes over your account and like just drains your account. That's the other use case. So I'm going to talk about both because it's kind of the way we solve it is very different. So yeah, let's talk about payment fraud. So any questions so far? I want to make sure like this is interactive because like I've already covered plenty of stuff. So if you have any questions, feel free to jump in any moment. Questions? Nope? Okay. Cool. So why is crypto like very appealing, right, for fraudsters, right? And turns out it's like very similar reasons why it's appealing to like a good user. It's also appealing to bad activity, right? So what are those things? First of all, cryptocurrencies are instant transactions. So that's a really good thing, you know, because you can send money from one point in the world to another point within an instant. But that makes it very hard to actually respond to this kind of attack where, you know, the money is being sent without your authorization. The other reason why it's appealing is it's non-reversible, right? So the one interesting thing about credit cards is you can go back and dispute any of your charges, and you can basically tell your bank, hey, like, this wasn't me. At least in the US, I actually don't know how it works in Portugal, but you can actually do that, and then they will sort of run an investigation and then try to give your money back. So this doesn't exist with cryptocurrencies, and that's actually by design, because it's a highly secure protocol, so you don't really have reversal transactions, because there's no really like dispute resolution mechanism. The other reason why crypto is appealing is it's hard to trace. So Bitcoin is what we call like pseudo-anonymous. So your addresses, your Bitcoin addresses, actually cannot be tied back to you, but you can actually figure out, like, if I can ever make a connection of this address belongs to you, then I can like sort of trace it. But it is very hard to do. Like, you have to have a lot of information about, like, you know, how does this address associate with this person. There's also other currencies which are like more privacy focused, which are completely anonymous. So you can't even like see where the transactions are going. So that's a whole another subject. But we can sort of talk about that a little bit also. The other thing is cryptocurrencies are very liquid, right? And so why is that important? So normally what fraudsters did is, one of the things fraudsters did is when they have access to credit cards, they can go and, for example, make some purchases, like go to Amazon, buy like a TV, and they have to like clear that out somehow. So like that's not very liquid. That actually like requires a lot of effort, right? To actually, you know, buy the thing, ship it to an anonymous location, and then somehow liquidate it. And then, so with Bitcoin, you can just steal it and then just go to an exchange and then cash it out. Like, super easy. Like, if you were a fraudster, this is like the best thing you can steal. So what does fraud look like on our platform, like specifically? So what we do when you sign up is actually we we need some information from you, like your email, like your phone number. You need to connect a bank. So we collect all this information. And what usually happens is like, this is one example of how fraud happens, and most of it happens this way. Scammers, fraudsters, actually collect many different sort of legitimate information from multiple sources, and then sort of combine it on the platform so that they can sort of pass all of the checks and be able to make a purchase. So that's like the bare minimum. So for example, if you have an attacker, you can imagine they steal Alice's bank account or credit card number, and then they can steal some other person, Bob's identity. And identity here refers to like social security number, some kind of like driver's license, anything of that sort. And then they can steal a third person's mobile phone and receive SMS on it. So they can combine all this information that has nothing to do with each other, and then make a purchase on our platform. So what happens then is Alice sees the charge on their credit card, and then she disputes the charge. The bank refunds Alice, and we had already given the Bitcoin away, so we take the damage. So that's what the problem looks like in the first payment fraud use case. So one of the ways we solve this is machine learning, which is very common, and sort of PayPal was like the first company to be able to do this at scale. So our approach is using sort of like a human-machine interaction system, where we can get the help of humans to actually feed the system with very useful information, and then train the system again to get that feedback, and then be able to catch the high-risk users. So the reason for that is mainly for one reason. And the reason is that fraudulent cases are actually very small. So if you have a data set, going back to your machine learning classes, I don't know if you've taken any, but I'll assume you did. So if you have a data set and it's very unbalanced, you have the problem of like adjusting the class weights. So if you don't have like a balanced data set, it gets really hard to identify and like correctly identify these small sort of class of bad users, right? So you can do a couple things to solve this, but you know, like it's very easy to get false positives. So you can like this really lets us like basically fails us like from having to get good users as classified as good users. So like a lot of the times we would end up classifying good users as bad users. So that would stop people from being able to purchase, and they'll get frustrated, right? So it's not really your sort of standard, you know, let's just try to get like a 90% accuracy on sort of the correctness. But you're also like trying to minimize the false positives by a lot to make sure the experience is good. So how do we use these signals? So like we have our fraud ops team, which is like sort of one side of our system, I could say. And they do a lot of labeling. So if they see any suspicious behavior, and they have like really good tools to detect that, they can sort of flag those users. So this is how we collect like labeled data, right? And then we can use this labeled data and be able to train on this, and then have a model that can identify the fraudulent transactions, right? And so turns out you can pretty much use anything about the user. So what are those things? I'll give you some examples. So like the fingerprint of your browser. So this is like a sort of like a unique identifier for your browser that's collected, not necessarily associate anything like personal information, but just happens to have this unique configuration of a browser that like results in a single fingerprint. So we can use that, because that's a pretty good signal of like your identity. And we can also use the location. We can use the phone number and your ID number and like different bank information. So as you can see, like the more sort of features you have this problem of like a lot of dimensions, right? So if you were to sort of just write rules, it would fall short, because then you'll have to, at some point, you'll have to come up with really, really difficult rules to cover for all these cases. So this is why, like, we use a machine learning system to be able to detect that sort of high-dimensional classification problem. And what we do is actually, instead of classification, we actually do a regression. And what that gives us is, instead of giving like a 0 or 1, like good or bad, it actually gives us a range, right? So it gives us a range from like 0 to 1. So now you can see like how fraudulent a user can be on a scale of like 0 to 1. So if you multiply it by 100, then that's like a percentage. So you can say like, this person is 10% fraudulent or the 20% fraudulent. So that gives us like a lot of flexibility on like what we can do with that number. Because remember, we are trying to minimize false positives, right? So we can actually use that number to make sure like we're at a good threshold, so we can identify only the bad users. And this is going back to more about like the high dimension space, which is one of the main like difficult problems, because you can get a lot of things like name mismatches, address mismatches. Like the data is like highly sort of unstructured. So you would get a lot of things like, Jonathan Kim versus John Kim, like for a first name, last name combination. And you have to really do like a lot of post-processing and make sure like your data is clean and reflective of the actual data set. And so why does it work also? Like why can machine learning like pick up these patterns really easily? One reason is the broken window theory. Like, because like fraud happens in sort of rings, right? So if you're a fraudster and you wanna make some money and you're actually like putting a lot of effort, like for you it's also a sort of like investment, right? You're investing time and then you're getting some output. So like you wanna be able to do this at scale, right? So when you're doing fraud, and you're like a seasoned fraudster, you don't do it like, one time. You want to do it at like a group of 100 or a group of 1,000, right? So you can actually make money. So what happens is there's a lot of traces we can check, because like if you do anything in a group like that, like a huge group of transactions, you can get pretty smart about it. You can like, sort of do one day and then like the other day, like you can kind of slow it down. But no matter what you do, you're sort of bound to leave some kind of trace and some kind of similarity across all the purchases that lets us identify the fraud ring. So this really helps us. Like for example, I have a few examples here. For example, the screen resolution, right? Like a lot of the earlier frauds we stopped, they had this common pattern. They were like 1 pixel off their screen resolution. They were 1 pixel lower, which turns out it's like a bug in the remote VPN connection. So if you like start the remote VPN screen, like your screen will be 1 pixel off. So like we sort of saw a spike in this behavior, and then we were able to pick up on the pixel resolution, and then be able to ban this combination. So there's like little things like that where you can have this system to detect like these small sort of seemingly insignificant features. And it's like a, like cat and mouse game, right? Like, because you block this behavior, fraudsters are like very aware of like their methods and like their systems and how they like approach the problem. So they can easily know that like, okay, something's wrong with my script or something's wrong with like however I'm doing this. So they can quickly notice like, okay, they no longer can do a VPN connection, like a remote desktop client. They can actually, it's like very, very fast. Like within a week, they're able to sort of get around whatever precautions you took and like come up with a new way. Because remember, they're doing it in scale also. Just like we're trying to prevent it in scale, they're doing it in scale. So going back to the risk score, that scored like from 0 to 100, right? So that's like the percentage, right, of like how fraudulent you are. So our initial approach was like, finding that like cutoff, finding this like cutoff where we can say, okay, after this, like above 95%, we're gonna ban everyone, right? And that was the initial approach, and that didn't seem to work too well. And the reason is, like I said, false positives. Like false positives are like, is your enemy, like in fraud detection, right? So what happens there is you end up blocking a lot of the good users, and they write to support complaining, hey, like I want to buy $100,000 of Bitcoin, and like I can't do it because like your system thinks I'm fraudulent. So that's like super annoying. So what we did is we came up with a limit structure where we can sort of separate users into different tiers based on their risk profile, and then sort of let them progress through these levels of risk profiles and levels of how much they can buy in a week. Later on, we did that daily. It was daily before. We started doing it weekly. And you can progress through this limit structure and then sort of build a reputation with us. So what do you have to do like to increase your limits from like the user's point of view? So it's sort of a couple of things. There's some like implicit things that you sort of do without knowing that lets you sort of progress. Like for example, purchase volume, and like your aging of your account. By the way, like Frost is also really good at like aging accounts, because that's clearly like a good signal of, like how fraudulent an account might be. So you would see a lot of like aged accounts doing fraud also, where like the fraudster opens the account, waits like 6 months, or makes some like legitimate transactions, and then 6 months later makes one big hit and then takes the money and runs. So that exists too. But it requires a lot of patience and investment, and they tend not to do that as often, which is good for us. So the other way you can increase your limits is you provide more verifications. And like we're kind of explicit about that. We tell the users, like if you want higher limits, you can provide us your driver license, like picture of your driver's license, picture of like a bill, so we can actually verify your identity, which also helps us with compliance as well, but that's a whole another dimension of like what we do. But as you provide like more information and more legitimate resources about yourself, you can progress through these limit structures and have a lower risk score. Any questions so far? Cool. So we call this system Precog. It's from Minority Report. I don't know if you know about the movie, but it's the system where like criminals are sort of detected by by the system sort of, you know, based on their previous actions. So like probabilistic to decide whether someone's gonna do something bad. So that's where the name comes from. And what we do is I'm gonna like describe a very high level architecture of like what this thing looks like, right? So we have like mainly two pipelines. And as like in machine learning, it's a very standard architecture. You have a training pipeline and a scoring pipeline. And a lot of the times, you can actually use your training pipeline to do the scoring as well, right? But for us, that doesn't work. And there's a very good reason for it. So we have to have two separate pipelines because when you're doing training, there is a problem of having stale data, right? Because this training data is coming from like a secondary analytics database, so that we don't affect the production systems, right? Because we're heavily rescoring users on every little action they do, because every little new information they provide us, it can change their risk score significantly, right? So we use the training data, and then when we're scoring, we actually grab the features from the real-time database, and then try to score with that feature vector onto the model. So this like actually is very challenging because, you know, that means you have to constantly train your data set and like have a fresh model, but also you have to maintain sort of two systems for both training and scoring, and you have to, it's very hard to share code between them because the nature of the computation is very different. One is like more batch, the other is more streaming. So talking about keeping the models sort of fresh and up to date, and you know, like using the latest data for your training and like being able to redeploy your models all the time, it's actually not a very good thing in our case. And you can see the reason why here. So I'll let you read this really quick. And you can probably guess why this happened, right? So basically, this is a user complaining about their limits changing. So what happened there, right? So we were trying to protect everyone. I mean, we were trying to mostly protect the company, right? So that's the main goal with payment fraud. We're trying to protect ourselves. So when we were trying to do that, what happened was we sort of shifted the scores in a way that's not very predictable. And since we have like a lot of users, like 10 million users, it's very hard to know whether like a given user's score is going to change, right? So what you need to do is you can't really just like deploy a new model as you wish, because if your scores change too rapidly, then your user is going to freak out. So what we need to do is we need to deploy a secondary model, like the candidate model. We need to deploy that quietly. So like we deploy that, and it's sort of in shadow mode, right? So what does it do? It actually scores everyone and collects like a lot of useful information, right? And we want to make sure this is like coming from, you know, like the production database. It's just like the first model, but we're just collecting data for now. We're not taking any actions. So we have to actually do this and collect a lot of data before we can say, okay, this model is good now. So one like sort of crude thing we do is between each of these models. So in here, you can see like two different models in each graph. The one on the left is your good user distribution. So the lower the risk score, the better the user, okay? So you can see like the first model, the old model, you know, has that kind of distribution. And then the new one, it's actually giving good users better scores. So it's actually better. that means like the good users will have lower scores, so that doesn't affect the limit structures as much. And there's like some sort of spikes that happened in the older model, but it's like smoothed out in the newer model, so like this is like a decent model to release in terms of good users. But we also have to look at the bad users, right? So that's the bad user distribution. And on the right, you can see there's like a dip in the old model. That means like the model, for some reason, the old model thought that there's like less bad users at 1, because we would expect the distribution to go up all the way with like the highest risk scores to have the most sort of bad users. But the new model actually does the opposite and like has this little dip, which is like not ideal, but it'll still keep the limits somewhat similar. But we're just, we just want to make sure that in the middle, we're not having like too many things that change, and we can actually measure the impact of the new model, and then only then we decide to push it to production. So this is something like they never really teach you at school, and like you get to discover this later on. Like how do you connect, like, sort of like this theoretical, like machine learning problem? How do you connect that to the business, and then be able to, sort of make decisions based on the business needs? And the other thing we do is we have to also have a lot of manual tooling to basically be able to sort of control the behavior of the system, right? Because if you have this sort of black box of this machine learning system, and it's changing limits left and right, and you want to sort of protect a certain cohort of users, you should be able to have some tools to let you do that. So we develop a lot of internal tools that our fraud admins can use to be able to sort of lock scores or move people through different level structures. So I'm gonna move on to more of the like unsupervised techniques we use. And before that, I wanna make sure whether people have any questions or not. Questions? No? Cool. All right. So where does like supervised learning fail, right? So like we already identified like few of the problems that we don't really have a lot of labeled data, right? Because fraud rate is really low, and so that's one reason. And the other reason is the chargeback window, right? So what does that mean? So chargeback is, and this can change really like depending on the country, but this is sort of like how it is in the US. So chargeback window is like the time you can dispute a charge. So if you made like a debit card purchase, which is called ACH also, you have 60 days to actually reverse that. Like it's huge, right? So like, the actual owner of the card doesn't have to reverse the transaction for 60 days. You can come back 2 months later and like say this transaction was fraudulent. So like we have this huge disadvantage about when we get the actual label of the data, because by the time we get it, like we haven't taken an action. And like we can't take an action because we don't know whether it's actually fraudulent or not. So this brings us to like the unsupervised techniques, right? Because of the nature of the problem, like we have a lot of similar attacks happening, and like fraud is happening sort of in rings, right? So we can use unsupervised techniques to actually detect these rings, right? So I'm going to talk about like anomaly detection, related user, and rules engine. So what can you do with like these patterns emerging? And like if you're not training your model too frequently, you have to make sure that you're able to detect these patterns really fast, right? So what we do is we actually sort of set a baseline for each of these attributes that we think are interesting. For example, like accounts with bank XYZ, right? So we can trace like the baseline sort of for that account. And like we would assume that, you know, that has sort of like a certain value that is always happening. And if we see a spike, that's most likely some kind of like data leak from a bank. Because what the fraudsters do is they get the data leak and then they want to cash out immediately because that data leak is actually in the dark market being sold for, you know, whatever. So like everyone's actually has access to that because it's being sold. So they want to cash out as soon as possible. So this is how we can detect, like without actually getting the chargebacks, we can see anomalous activities on banks and then really say like, you know, there's something fishy going on with this bank. And this doesn't usually happen for like a single attribute, which is just the bank name here. This happens like in like combinations of attributes. So you'd have to do this with like different combinations of attributes. So like, you know, bank account X with like telco provider Y, you know, and you'd have to trace that as well. So we have like a lot of monitoring systems that detect this and sort of generate reports on demand so that we can take action on these accounts. The other thing we do is related user discovery, right? So what this means is we're trying to basically, again, like using the property of fraud happening and having like common properties. What we can do is like we can detect, whenever we detect fraud and like an admin identifies as fraudulent, we can go back and like bring to the interface, we can bring like a list of related users. So if there is like a lot of like strong attributes that are like relating these users, the fraud experts can actually go in, delve in and see, okay, you know, like out of these 10 accounts, this definitely looks like someone, you know, like actually created all of these accounts and they're trying to fraud us. So they can sort of like batch ban all of these accounts. So that's one way. That's like using sort of attributes, like strong attributes. And then the other way is we can also use sort of more numeric methods, like cosine similarity. So like we can get the whole sort of like what like the feature vector looks like, and then be able to match users based on that without like these strong attributes. And another way is also like being able to generate these rules that the fraud analysts provide, being able to generate these rules and then be able to push that to production as soon as possible, and you know, disable or like require some kind of more information on these accounts. So that's like the third thing we do. And this is easy, sort of, we developed this like custom sort of DSL for analysts to be able to like write rules like this. And you know, they can sort of specify like the combinations of different attributes and then generate like different monitors on top of how these are progressing, and then be able to take actions on those rules. So when you create this, you know, we also automatically generate the monitoring tool for it. And I'm going to show you like some examples of like the type of things we get. So like a couple months ago, we detected this ring with Verizon, which is like a telco provider. And it looked like this. So, so there is like something interesting here. I guess you can sort of detect it. Can you? Can anyone see the difference? Yeah, yeah, it is photoshopped, right? And it's not even like, they didn't even try that much, right? Like, it's kind of like, yeah, just one number, I think. Oh, they changed this one too. It's pretty well done. So like, but very small effort, you know, for like, I don't know, maybe like $15, $20 fraud. Like, it's totally worth it, takes 5 minutes. But the problem with this is, when we actually, like, looking at these IDs, like, there is no sort of centralized system that can say, like, oh, this ID has been uploaded before, or like there's no really like good way of fuzzy matching these things. And especially we're using like external vendors for like verifying IDs. We don't really have access to like these IDs to build those systems that can check like image similarity across different accounts. So to prevent this, we actually start storing IDs on our own into very securely, and then be able to train some systems to detect ID similarity. So if you have any multiple IDs on multiple accounts that are looking very similar, so we can surface that and like tell the fraud analyst, hey, there's something fishy going on. We're getting too many of these similar IDs, even though they are very, the ID numbers are different. Sometimes the name is actually photoshopped. Like there is a lot of things photoshopped. And like we can surface that, and then they can sort of manually go through and identify. So this particular ring was, they actually had around like 40 of these images, all of them photoshopped by hand and with different driver license codes, right? So they knew like, we were looking at the driver license number, but like nothing else, so they only changed that, which is like, it's pretty smart. But so another thing they have to do is, they also have to get like phones, right? Like we also require, as you remember from the sign-up flow, like we require phone numbers as well. But like turns out that's super easy too. You can just like, there's literally like free online phone number.com. Like you can go and just like send a message to this pool of numbers, and then you'll see the messages that number gets, or that pool of numbers get, in like this common shared screen. So it's like, having like 10 free numbers and like 1 million people can like use those same numbers. So it's kind of ridiculous. Like, so it's very easy to get around. We do collect a lot of data about phones as well, in terms of like sort of matching different, like telco provider also has information about like your name, so we can actually match like your name you put on the account versus like the name on the phone number account. We can also somehow like get some information about whether it's like a VoIP number, like a Google Voice number, things like that. And our model just internally figures out those are pretty strong identifiers in detecting fraudulent behavior. Yeah, and I'll actually talk about this a little more later on when I talk about account recovery. I just want to actually check up on time. How am I doing with time? Just so. Okay. Okay, cool. So almost done? Cool. So let's see. Yeah, so like we detected this ring not because of the ID. Like the ID we actually discovered later on, they had like 50 IDs that are the same. We actually detected it from screen resolution. It was like an off-screen resolution that like not a lot of people use. And we saw a spike in there, and like we were looking at these list of fraudulent users, and we found this very strong attribute that were being shared. So we just like pooled all the accounts with images, and all the images were the same. So it was somewhat an accident, but we ended up saving a lot of money from this particular ring. And I'm just gonna like show you a few more examples of like weird stuff that fraudsters do. This is actually like a sad one. We classify these as like romance scams or like tech support scams. There was like a crazy resurgence of this last year, where like you would see a lot of people on their phone holding their ID because they're actually being instructed to do so. So there's someone on the phone telling them, hey, blah blah, like I'm your grandson or something, and like I need money. And, like they literally walk them through opening a Coinbase account and like getting their ID verification and then like getting money from their accounts. So this was huge, and like we had a prototype that can identify if there's like a phone being held in the picture, so we could flag these sort of these images with like a phone in their ID pictures. But luckily, like this didn't go on for too long. This is like a crazy Photoshop skills. So there's a lot of selfies like on social media, right? And like we rely heavily on selfies for like face match and stuff. So on the right, you can see like the photo of this lady from a social media website, and they had stolen her identity card, like their driver license, but they needed a face, so they like crop this face out, put that in, put like a number, like that's someone else's hand, and like they like did like some haircut on like something weird, and like this is to sort of prove that they were who they were saying they were. And they even have like the date on the side. But I mean, we were quickly able to sort of get the original photo by like reverse image search and then identify them. There's some other face match. This one is like my favorite because they like align the face exactly with like the body, but it's actually a printed out photo. Again, like, since we require a face match, like a selfie along with the ID, if they only have an ID, which you can easily get by like, hacking someone's Dropbox account, like all IDs are online, so like it's not very hard. So you can get that and like, print out a photo and hold it. And that one is kind of funny too. There's like, you can see the guy like holding up. And that guy like didn't even try really. He's just like, that's someone else's ID, and that's actually the fraudster himself. So, and this one is just kind of ridiculous, like Microsoft Paint. Yeah, so here's like some takeaways, basically, like we have all these new challenges that are introduced by digital currencies, which is like the reversibility and like the speed it happens, and we have to take some precautions for that. And we also like, we also figured that, like having this ultimate machine learning model like doesn't really help. You have to build a lot of things around it to like actually solve the problem. And you also need a lot of help from humans to actually be able to feed the system with valuable data so that you can do this in scale. So I wanted to talk about account takeovers as well, but I might be out of time. So I'm gonna have to stop here and skip to the end slide and get any questions you might have about payment fraud. And that's my team in San Francisco, and we're hiring.